So as Ellie said, we're in charge of data loggers. Michael's going to share his screen as he gets that up. Just as a preface, so this week we're just doing instruction here right after spring break, and we'll put these details in Slack and everything. But right after spring break, we will be meeting in the third floor Chemi unit operations lab to test out and use and get practice using this equipment. So keep that in mind when we're going through this today.
So we are going to start by discussing the HoboWare data loggers that we use frequently on assessments. So shown here on this screen are, the data loggers that hopefully most of you are familiar with. The data logger itself, what we refer to as the data logger, is this boxy looking thing with the screen on the right. This is the apparatus that records the information. Data loggers come in various types. This one shown on the screen is a 4-channel external logger. Means that it has 4 jacks on the bottom where you can hook in these external sensors. We have other data loggers that have internal sensors for temperature, for relative humidity. We have some that have a little dome on them that senses light, which we can use to determine occupancy, like of an office. We have some loggers that are for motor on off. They record the magnetic field associated when a motor is turned on. So they just show you how long something is running. We have some that receive thermocouples to take temperatures. And then we have others that are like this one kind of on the bottom left, which are Bluetooth enabled. These are some of our newest ones. I think we've got most of the kinks worked out of these. Our Bluetooth loggers they have an internal temperature sensor, an internal relative humidity sensor. They have an internal light sensor, and then they have one external channel. So with that external channel, we can connect current transducers or CTs. CTs record the intensity of a magnetic field that is caused by current flowing through an electrical wire. So in that way, they allow us to determine what the current flow through that wire is, the amperage flowing through there. And we have various sizes of current transducers. We have 20, 50, 100, 200, and 500 amp CTs. And you should select the CT that is the right size for the peak application that you are anticipating flowing through that wire, because that will give you the best resolution.
Just a note for all the new students, we had 2 weeks ago, we did like the really new cohort. If you remember, we looked at nameplates a few weeks ago. On the nameplate for lots of machinery is a full load amps or an FLA. That's a good place to look when you're looking at the size of a CT to use, but we can talk about that in a bit. So with these loggers that we have 2 different software packages, unfortunately, because some of them are older and some of them are newer. So one of them is HoboWare. Raise your hand if you have not used HoboWare before. Okay, a few. Okay. Raise your hand if you don't have HoboWare downloaded on your computer. Okay, and I know that some people who have Macs have had problems with HoboWare before. One of your assignments for the class that's going to happen right after spring break is to make sure you have HoboWare downloaded. So HoboWare is the one we use for the older loggers, everything that has to plug in to connect. We use HoboWare to connect, and it's only available on computers. It's free. So there's a link here. Michael and I will post the link, but you have to, if you could, please download that so you can learn how to use HoboWare on our on-site trainings. The other one is called Hobo Connect. It's all made by the same company, Hobo. And Hobo Connect is available as a app on your phone and also an app on your computer. And so that's available at this link here, and that's how we connect to the new Bluetooth loggers. So for our training in 2 weeks and 3 weeks, we need everyone to have access to both of these softwares so that you can learn how to use both of them on site. And be familiar with them and be able to launch loggers. So your assignment from Michael and I, other than getting questions and giving us questions is to download both of these and have them available to use, if at all possible, in 2 weeks when we do our on-site training. Any questions about that before we keep going? Okay.
Yeah. Once you do have the HoboWare software downloaded, you'll see this welcome screen. The important buttons are up in the top left. These icons up here are for launching the loggers, for reading out a logger that's currently going, or for stopping a logger or reading out its status. Now, in this screen, you'll see I don't have a device connected. It'll indicate a device is connected in the bottom right corner. And on the next, so if you're ready to launch out a logger, you connect it with a USB to a micro USB just through on your computer. And you'll see when you get ready to launch a logger, you'll see something like this. This is to launch one of those 4-channel loggers. First box, you can enter a name and check the battery status. And then on loggers that have external sensors, you'll see a box here in the middle where you'll have to select which sensor you are attaching to it. So just click the bar. A drop-down menu will open where you'll see things for AC current, for AC voltage, for all sorts of other sensors you can add to it. Our loggers are AC current sensors. Just hover over it and select the size of the logger or the size of the CT you're connecting to it. And that will tell it, I'm using a 100 amp CT. And then in this deployment box down here, you can select the logging interval and select the logging mode. We'll talk about those a little bit more on the next slide, but logging intervals can be anywhere from 1 second to like 18 hours. And that's how often it takes a measurement. It will, based on the interval that you specify, it'll tell you how long it can sustain that memory. You can also then tell it when you want to start logging. So usually we like to coordinate all of our loggers to start logging at a specific time, sometime after we have had a chance to launch them and set them up in the facility. So give it like a 2-hour delay, have them all start at the same hour. And then that way, when we read out the data, they all start at the same time. And then you hit start at the bottom. The delayed start button will come up. If you've specified it to start sometime in the future, it will write the data to the logger and tell it to start at the moment you've indicated. If you are telling it to start immediately, for example, it'll just say start. For the Bluetooth loggers, you go into the HoboConnect app and it will connect to the loggers it senses in its proximity. You tap on the one that corresponds to the one you have in your hand that you want to launch. You can check the serial number on the back to make sure you have the right one. And similarly, one of the blue icons at the bottom will be to edit it. You give it a name, you set up the duration of logging and the intervals. And there at the bottom, you set up the external sensors if you're using an external channel, and then you hit launch. There are some options. We don't really frequently do anything with other types of logging modes, but normal just means at fixed intervals. Burst means it'll take more measurements more quickly for certain sensors, for certain readings. We don't really do that a whole lot, but this is just some useful information for other options if there is a need for that. I'll let Blake talk about the dangers a little bit.
I can talk about the fun stuff, my opinion. So we've talked about this. I'm pretty sure everybody has seen the safety video. If you haven't, don't tell me, just go watch it tonight. IAC students are never allowed to work in energized electrical cabinets. We just don't have the training as electricians to do that, to install CTs on live wires. So in most places we go, these are high voltage situations, as much as 480 volts usually, that we're working with. So always have an electrician install these, and we will show you on the on-site training. that we do in 2 weeks. We're going to show you what these wires kind of look like, make sure everybody knows what the electrician's looking for and things like that. But you will never be doing this yourself. But you will be able to you'll be able to be there with the electrician. You'll be able to open the CT and you'll learn about what these look like, how to open them, and things like that when we do our on-site training. But you'll be able to open it, hand it to the electrician, and then the electrician will put it on and they will snap it shut and put it in the box all themselves. One of the reasons that we do this is because of a thing called arc flash. Has anybody heard of arc flash before? Hopefully you have. Michael and I have a nice, sweet, awesome short video that we're going to watch on arc flash. So hopefully this works.
Here in this high-power electrical testing facility, we're going to find out why arc flash and arc blast are so dangerous. Let's check out the final preparations. We're going to energize this power panel, similar to the type found in almost every industrial facility, to see what happens when we create an arc flash. But first, I'm out of here.
We're ready to test. 3, 2, 1.
A worker has no chance of getting out of the way. An arc flash can reach 35,000 degrees Fahrenheit, causing disabling second and third degree burns in seconds. It creates a pressure wave called an arc blast that can reach thousands of pounds per square inch, enough to knock someone off a ladder, rupture an eardrum, or collapse a lung. It'll blow equipment apart and propel shrapnel with enough force to completely penetrate a worker's body. An unprotected worker could be severely injured or killed.
Sweet. So just a note very quickly. Hopefully that encourages everyone never to go into a live electrical panel without proper training. But we'll talk more about that in safety. And if you have any questions, you can talk to me or Michael about safety and arc flash.
Yeah, safety is priority. Thankfully, we almost never have need to even mess with that. We ask people to have electricians there. So we'll move on quickly to the other use we have for loggers, which is for pressure logging. We have some pressure loggers which measure gauge pressure, so we can get information from an air compressor about what the pressure they're putting out is. We have 200 PSI and 100 PSI sensors. We can power them either from a wall outlet or from a battery pack. And we have a cheat sheet for how to set those up available on the box if you are unfamiliar with it. Basically, these just plug into a compressed air outlet somewhere on the compressed air system. We like to set that up close to the outlet of the air compressor so that we get outlet pressure. It's also useful to get an electrical amp reading from the same compressor so that we can correlate the air pressure with the power draw of the unit. We have a bunch of fittings and adapters that will help you to install it. The transducers are 1/4 inch pipe thread. We have 1/2 inch adapters, and we have some quick connects. Use Teflon tape when you're putting them on to get a better seal. When you put them on and take them off, make sure the isolation valves are closed. And if you remove an existing manual pressure sensor, make sure to replace it when you take them off. But otherwise, these are pretty useful. And I think that's the end of our presentation about data logging. Any questions, or should we move on to the next?
All right, so I'm guessing everyone's an expert on data logging, and they'll be able to do without us on site. It's great. I have a question. Here's a quick question. There was one assessment, I can't remember which one it was, but they were doing pressure logging and they made a mistake and it ruined their pressure logging data. Can somebody comment on that? Is that Parker? Yeah.
That was my group. We accidentally programmed the loggers to log CFM instead of PSI. So that's when the data got ruined. So make sure when you're doing the pressure logger, it is PSI, not CFM.
Thanks, Parker.
Okay, I think we can move to RT. RT, are you ready to present about the ultrasonic leak detector?
Yes, let's
Okay.
do it. As I'm pulling it up, here's an air leak joke for you. What do you call an air mattress with a slow leak? The floor. All right, so today we're going to be talking about how to utilize an ultrasonic leak detector. I've made this
presentation. Switch your presentation.
Dang it. What do I want you to do? Display settings?
Yeah.
Swap. Are we good now? Thank you. All right. So today we're going to be talking about how to utilize the ultrasonic leak detector presented by me. A more informal way to say that is, let's see what chefware T cooked up today, as a moniker I sometimes go by. So let's get to it. The ingredients of this recipe are to give an overview of the device, how to operate the device, uploading the data to a leak reporter, and we will finish with a recap. So let's talk about an overview of the device, which quick shout out to Andrew, who's going to be featured on many slides in this presentation. So this device that Andrew is holding here is our ultrasonic leak detector. It's this kind of apparatus. It's only his hand with a flexible sensor that comes out. And then you got some headphones that you put over your ears to help do it. Just reiterating this, we're talking about an ultrasonic leak detector. It aids in identifying air leaks on site. And the reason why we really care about this is because air leaks obviously cost money, because you have to put more energy into the system to receive the same end goal if you got air leaks. Let's move on to how to operate the device, which, quick note, gloves are not included. So if you want that stylish characteristic, you're gonna need to include that yourself. Step one, have a great attitude. I really enjoyed this photo of Andrew's. I thought I included it. By the way, what do you call an acid with an attitude? Amino acid. So don't be amino acid and things will go well. So step two is to make the apparatus happy on that topic of having a great attitude. Number one is you'll turn it on, obviously, and then you're going to hit the up and down button. So if you're looking at this figure in the top left, this is our apparatus when it kind of comes on originally. You're going to hit the up, or I should say in the screen here, I've got battery level, we got an A = 30, we got some lines, and we got an arrow in the top left. That arrow is telling you that we need to change the current amplification upwards. That A value at 30 needs to go up. So you're going to hit the up button until there's a nice little lovely smiley face in the top left corner. And then it will be happy and you'll be happy. And if the numbers, so the number's green here, if the numbers turn red and you lose your smiley face or anything like that, you can turn down the current amplification and it'll be happy again. During an assessment, you can change the amplification during it, just make sure it's happy for whenever you're giving a readout. And the reading, what it's reading is a decibel, the sound level that's coming out of the air leak. So then you also need to plug the headphones into the bottom of the apparatus. And then when you do that, an icon comes up in the bottom left. That is the sound volume. You're going to hit the left, right arrows to adjust the volume. And that's basically it. Now you're ready to go. So step three, you're going to point and listen. So you're going to follow air pressure lines. So look at things such as air compressors, if there's hand tools coming off of that, and when in doubt, just follow the lines from an air compressor. As you can see, our lovely model, Andrew, again, here on the left, he's got his apparatus pointed at what appears to be a compressed air line feeding into some apparatus. Through the headphones, you can listen for noise. Obviously, when it's louder, you're hearing an air leak typically. Can be slightly confused with manufacturing noises, but it's actually really good. So also just use common sense with that. You can also monitor the readout to locate the spot, find where the readout is going to be largest, and so on. One other quick trick of the trade here, if you're really not sure where you find it, you can just kind of run your hand on kind of along parallel with the airline if you're able to, if you're close to it. and it's safe. And then you can determine also where the air leak is. So then step 4, we gotta record our readout, right? We want to do something with our data in our air leak so we can recommend something. There's 2 ways to go about this. The preferred way is through the Leak Reporter app, which I'm going to talk about in a moment. And second is pen and paper, as we're seeing Andrew do here. Pen and paper is always a good backup too, but I really enjoy the Leak Reporter app as a tracking measurement, and so we're going to talk about that. So we are going to upload the data to Leak Reporter. Leak Reporter, am I doing that a lot? Or, oh no. Leak Reporter, on which you can see on the right side of the screen here, is an app, both Google Play and Apple Store. Plus, they also have an online interface that you can use, and you can basically log all the air leaks on site that you can detect, and then use those at a later time in a helpful manner. So I guess going back, that's my one task. I'll add that to the tasks you've been given by Blake and Michael, is that you all will need to download the Leak Reporter app. I'll send something out about that. And you'll need to create an account, so like log in. It's super quick, super easy, and it's a friendly interface. So then on your phone, you got the apparatus going, you find an air leak. On your phone, then you're gonna open up the app, and it's gonna appear this figure all the way on the left, this first one. It's gonna show all the surveys you've done. So this is mine. I did a test survey just to try things out. And then in 2 different assessments, I created surveys where I tracked leaks. You can see at TradeStar found 11, IFA Draper found 6. You're gonna hit this new survey button in the bottom right, that figure. And here's the really great thing about this app. It really tries to help explain everything that you need to successfully log data. So this yellow screen pops up saying new survey, getting started what you need, and it lists out exactly what you need. You need your leak detector, you need the flexible sensor, which is what we've already talked about. You got that, that's basically part of the sensor. Detector, the number of hours per year that your compressor operates, and your company's cost per kilowatt. And that's what pops up then on the right. I highlighted the green circles are things you need to change. So the name it whatever you want. I create a new one for the purpose of this called trial 1. I didn't mess with the kilowatts, kilowatt hours per meter cubed or squared, whatever it is there. I just left it with the standard heuristic or whatever that they use. I changed the price to be 3 cents. I changed the currency. Its default is euros, so you'll want to change that into dollars. And then currently the units metric, it's probably more helpful to have it in imperial. And then lastly, the yellows are things you can edit at the time if you want. So I just go with the automatic tag number, but if you're like, I really want to interact and name my tags, you can turn it to manual. And then also hours per year, you can input that if you know it. If you don't know it, you can just go with whatever it says at the when you set up, like 8760, and then at a later time you can update those hours, and it will still work okay. You'll be good. So you got your survey set up, you got your apparatus on, we got great attitude. Now we're going to add the leaks to the report. So you're gonna, I mean, it had a lovely arrow in here. I didn't even have to add one. It just says it's on the app. You have not inserted a leak. You can do it here. And so then you hit the new leak. Another wonderful yellow screen pops up there telling you exactly what you need to do. And then the 2 figures on the right are basically, it's one thing that you'll see. I didn't have enough room in one screenshot, so I did it in 2. And the first step is, I really like this. You can take a picture. It has a wide angle and a close-up, and it has a yellow bullseye that comes up in the photo, so you can pinpoint exactly where the leaks are. And I'll show you that in a moment too. Like that, you need to put in how far away you are from the leak. So 20 centimeters, or if you're in imperial units, 10 inches, whatever it may be. The measurement is what's reading out on your apparatus. So if it's 10 decibels or 30 decibels, whatever it may be. Then the location, you want to say, where the location is. Those are the green ones, the things you really should upload. The ones you can change are the tag number. Again, that's if you had, in this slide, you have selected manual tag number. at the bottom right. Then you can put in your own tag number. Since I selected automatic, it'll just say my first report is tag number 1. My next one will be tag number 2, and so on. I just leave all status as low. I don't know why you would need to do anything else. And then notes and comments. This is the one thing that this app doesn't have that you will probably need for calculations is you need to record the line pressure either here in the notes and comments or at a later date. Or I mean in your notes so they can use it at a later date. And then finally here's an example of the leak. So I file the leak, whatever. I come back from my site visit and I want to revisit it. So as you can see here, I was the person who did it because I put in my birth name of Matthew Williams. My data location was June 3rd. It's got the flipped dates there. And the survey's trade start. It's got the wide angle. So you can kind of get an outside shot with a pinpoint and then a close-up, really see where that air leak is. Location tag number where I put in there, I put in the distance from the leak, and then in the measurement, the decibel, so 63.8. Everything else, and I put in the hours per year. Everything else, the app automatically calculates for you. It calculates probably the air loss for the year, potential loss, energy or cost of those air loss throughout the year, and so on. So my last thing to add here is getting the results. So once you have that all in there with the app, you then go to their website, and there you can actually activate or select your survey, gather the relevant information such as you can print a whole report for yourself or the client, and they'll also have potential savings, which is really nice. So here's my recap. The device is very intuitive. Find the smiley face and just listen for the things. Point and listen. Here's a fun fact if you didn't know this about me. I am legally deaf. I am completely deaf in my left ear and I'm moderately deaf in my right ear. I have had no problem using this equipment. So if a legally deaf fellow can do it, so can you. And then lastly, upload the information in the app and you can always edit it at a later time in the survey online. Thank you, and I hope you enjoyed this recipe. See, we got one question if you want me to answer that. Measured decibel will be changed when you change the device.
Oh, yeah, so that was my question. So I remember when I used this device before, so I found that you can change the device volume. So at the beginning, for example, if the volume is 60, the measured number is 60 dB. And then when you turn up the volume, it could become 100 dB. So in this situation, how should we deal with that? Do we have some standard?
Are you talking about the A value, the current amplification, or are you talking about like the volume into your headphones?
I cannot remember clearly because that was a long time ago, but I just remember there's a button if you change that, the dB number will be changed.
So that's probably with the current amplification, that A value in the bottom right of the screen. It does have like some effects, but the big thing is, in my experience, if you just make sure the system has a smiley face, even if it changes slightly, you should be okay. Because I think a lot of it changes based on like how far away you are from the air leak and things like that. So once so it's trying to amplify itself, things of that nature. That's at least in my experience.
Yeah, and it's all relative. So basically what you're doing is putting that up and down is you are taking into account the ambient noise, right? This is all ultrasonic, this is all about noise. So you're taking in the ambient noise to as low of a level as you can, and then it gives you that little smiley face. So the smiley face says, okay, we're accounting for the ambient noise. Now show me some new noise. You put it next to where a leak is, here's that noise, and it's all relative to what the ambient noise is. So all you're doing with those arrows is taking into account the ambient noise. So it's going to be different every place that you go because the noise level is different every place you go. And that's kind of what RT was saying. If you go to a different room and you need to press those up and down, that's what's going to be important. is making sure that you get that smiley face.
Okay, yeah, thank you. That answered my question. So the smiling face is the key.
I have a quick question, RT.
Go for it.
How do you know how far away you are? Like, do you kind of just guess it, or do you carry like a, I don't know, like a ruler with you? Or like, what's the best practice for that?
Yeah, just estimate. I mean, typically, I'd say 3 out of 4 times, like the compressed with the air compressor, the compressed air lines, you'll be pretty close to it. So you can almost put it up right next to the air leak. And so you can just say, I don't know, I'm 5 inches away, you know, or even 2 inches away if you really want to get that close, something like that. Obviously, there's going to be more guesswork if you find an air leak, say in the ceiling, and you're going to be pointing up. But most of the time, you're going to be close enough where you can just say, I think this is like 2 inches or whatever it is.
Okay, cool. Thank you.
Hopefully on site next week or 2 weeks, Nathan will find some that are different places and we'll try to make you do that. We'll work on that.
All right, sounds good.
Okay, thank you, RT. Yunji, are you ready to explain us how to use the thermal camera?
Yes, so I'm ready. Can everyone see my screen now?
Yes, we can.
Oh. Okay, so I'm going to introduce how to use the FLIR thermal camera, the forward-looking infrastructure thermal camera. So this will be very easy. So the first thing I want to talk about is when do we need the FLIR? Those are for the equipment managers. So before the on-site assessment, you have to think about something and decide whether you need to bring the FLIR. So I have checked on our AI checker and I noticed that in most of our situation, when we need the FLIR is we need to do something like installation AR, which means that for the installation AR, you want to calculate how much heat you lose from something, for example, from the pipeline, this one, from the boiler or from some oven. So if you want to calculate the heat loss, you need to know the inner temperature and the actual temperature. So you get the temperature difference and then calculate the heat loss. In this case, you need to use the FLIR to measure the surface temperature of those pipeline or something that you want to measure. So here is our FLIR package. It's very easy. We have manual, we have this camera, we have card reader because there's a SD card inside, and we have a charger. So the manual is very easy. It's only 2 pages. So if you are not sure how to use that, for example, you want to know how to turn on the equipment or how to check the historical picture or want to change the emissivity, I will introduce that later. You can always check the 2-page manual. So it will be very easy. And then here's the step to use the FLIR. Well, before the on-site assessment, those also for the equipment manager, the first thing is to check the battery to make sure it still has the electricity. And the date and time here. So just make sure the date and time will be correct. Otherwise, sometimes you might forget which picture you took when you write your AR or do your calculation. I also check on the SD card storage. I have checked on the storage yesterday. We still have plenty of space, so you don't have to worry about it recently. But in the future, if one day the SD card is full, so you don't want to. Yeah, you don't want that situation. So the on-site assessment, the first step, just turn on the camera. And the second step, you need to set up the emissivity. This is important, I will introduce later. And then take a thermal photo. And then the last step, save your photo and turn it off. And after assessment, you can just download the photo from the SD card. Very easy, just like how you use your camera at home. So now I want to introduce the concept which is important to use in the FLIR, the emissivity. So here is the emissivity concept. I grabbed it online. So the emissivity is something physical property of a material. So the emissivity is from 0 to 1. The maximum is 1. If the emissivity is 1, which means that that is a black body. So for the emissivity, you can see this picture. For some material that is rough or black, like this black pot, the emissivity is near to 1. But like this polished aluminum pot, it has a very low emissivity. So I also grabbed some typical material emissivity that will be common in our on-site assessment. You can see the polished metal, like a mirror or something, the emissivity is very low, close to 0. And the concrete is around 0.92. Like if you want to measure some building temperature, you might want to use the concrete emissivity. Or the gray pan, black pan, those are the pipeline. The pipeline will have different pan or black rather. So how to change the emissivity on the FLIR? I just grab the picture. So you can just follow the menu, go to the emissivity setting. So the machine has 4 typical emissivity number. So you can just, according to the material you measured, and then change the different emissivity number. You can also customize. So here I just want to emphasize why the emissivity is very important, because yesterday I have checked on the historic thermal camera picture from the SD card. I can see most of us didn't set up the emissivity correctly. So we can see the epsilon here. Here is the emissivity. So after you take a picture, you can see the emissivity here. So here is my teapot. I just do the experiment, very little experiment today. If I set up the emissivity equals to 0.95, the temperature is 115 Fahrenheit degree. But for the same teapot, if I set up the emissivity incorrectly, set up to 0.3, actually the temperature can go up to 184 Fahrenheit. So it does make a really big change. So you can see here, I Googled the emissivity of glass. So the correct number should be, I think 0.95 should be a good number for this one. So the emissivity, it does make a big change. So just make sure every time before you use that, the most easy way, just Google the emissivity of the material you want to test, and then you can input the correct emissivity and then take a picture. So about how to take a thermal photo, here is the step. The first thing is you pull the trigger and aim your target with the laser. So for the camera, it has an internal laser. So when you pull the trigger, you can use the laser, it will show this red laser spot. So you can use the laser to aim with the target you want to take and then take a picture. So after you release the trigger, if it shows like this, yes or no. So you just click on yes, which means that you want to save this photo, and then the photo will be saved, and then you can check on it later. So that's everything.
Junji, I have one question.
Yes, Julie.
Who is the person on your cover page with the thermal camera?
Yes.
It was you yourself?
Yeah.
All right.
Okay, thank you, Yunji. I will share my screen to let's see, to talk about the flue gas analyzer. Okay, so I'm going to talk about another instrument called flue gas analyzer. But why we use a flue gas analyzer? We have some different ARs that are related to knowing the specification of flue gas. And for example, some of those ARs are boiler tune-up or add economizer to boiler. If we're having a boiler tune-up AR, we actually looking for an optimum air to fuel ratio, and that's the main thing that we should consider for boiler tune-up. And we might recommend the facility to use some technologies to have the optimal ratio, like oxygen trim system that provides the feedback to the burner to control the amount of excess air to the combustor, and in the optimal level. So in order to see that if our boiler is running efficiently and have a optimal range of oxygen, we need to monitor the oxygen level in the flue gas. So we need a flue gas analyzer. Another potential AR related to boiler or furnaces can be adding economizer to boiler or stack heat exchanger. It actually gets the heat from the flue gas in order to preheat the stream to the inlet stream to the boiler. So in order to recommend the facility to add a heat exchanger for their stack, we need to know the stack temperature. But what is a flue gas analyzer? So as you can see here, this is a kit, a flue gas analyzer kit. It's an instrument to monitor the composition of flue gas of a boiler. And we can determine if the mixture of air and fuel have the proper ratio. And we usually can get the oxygen, carbon monoxide, carbon dioxide, boiler efficiency, and flue gas temperature data from this instrument. It's pretty simple. You connect this section to the monitoring device, and you use this probe. And as you can see here, this is a picture of me and Lexi while we're trying to use the flue gas analyzer on a stack of a boiler. You connect the, you put the probe in the stack stream, and you can, you should wait for about 1 minute until the numbers are stabilized. And then you can see something like this one, this picture. You can save this using a save button, but just in case if it doesn't save, I recommend you to always take a picture of it. So as you can see here, we can see the oxygen levels, ppm of CO, boiler efficiency, or the temperature of the stack. But what we're expecting to see when we're using the flue gas analyzer. So we need to have a sense of what the test results should be. You should know that the inadequate excess air would result in incomplete combustion, and you might see a high CO level. But on the other hand, if we have too much excess air, that will result in a heat loss, because we're increasing the flue gas flow. So typically on a well-designed natural gas fire system, we're expecting to see the oxygen level to be up to 10%. For other things like CO, in a natural gas fired boiler, we expect to see less than 100 ppm CO level. And for the oil or coal fire appliances, it should be less than 200 ppm. The flue gas temperature should be less than 200 centigrade degree. And if you're dealing with the flue gas analyzer and you want to do the energy efficiency for a boiler, as a rule of thumb, you should know that you can increase the boiler efficiency by 1% for each 50% reduction in excess air, or for 40 degree Fahrenheit reduction in stack temperature. And other things to consider when you're using flue gas analyzer. So when you're using flue gas analyzer, it means that you're dealing with boilers or furnaces. So I recommend you to always ask the facility if they, how often they tune their boilers, and if they have any oxygen trim installed on their boilers. And in order to complete your AR and to have all the information, make sure you take a picture of boiler's nameplate and ask the boiler's runtime. And for air quality analysis and suggesting any emission control on a boiler, make sure you know the burner type of the boiler. And yeah, that was my presentation. So I think we ran out of time. And if you have any question about any of the instruments that we were talking today, you can ask your question on Slack. And yeah, is there anything else?
Like just really quick preview what we'll do in the next couple weeks again.
Okay, so the next week is a spring break, and the week after that we're doing the on-site training, like Blake said, on the 3rd floor MEB operation lab. I think I will post it on the Slack, the exact location. And for the week after that, we're doing assignments and do the data analysis.
Great. Okay, fantastic. Thanks, graduate students. Nice job today. Great job. Appreciate it all. If I don't talk to you all before, enjoy your spring break. But I'm sure I'll talk to you a lot before then. So we'll see you for